Good morning. So in the last class we've seen about elasticity. We've seen few definitions of elasticity, plasticity, stress, strain, etc. We've seen what perfectly elastic and perfectly plastic bodies are, and we've also seen different types of stress and strain, like normal stress, tangential stress, or tensile stress or compressive stress. Similarly, linear strain, volume strain, as well as shearing strain. Also, we have seen Hooke's law, which says that provided the strain is small, stress is proportional to strain, or stress by strain is equal to a constant known as modulus of elasticity. So we discussed all these, and today we will be discussing different types of modulus of elasticity. The first one is Young's modulus. In Young's modulus, in this case, the deforming force is applied along a particular direction, and the body is subjected to a simple tension or simple compression. The force applied per unit area of cross section is called longitudinal or linear stress, and the change in dimension per unit length, or the change in length per unit length, is called longitudinal or shearing strain. So the ratio between this longitudinal stress and longitudinal strain is known as Young's modulus. And longitudinal stress is given by force per unit area, so force by area. And longitudinal stress is the change in length to original length. Here you can see a body and force is applied perpendicular to it along the surface. So the original length of the body is capital L, and the length there is after we apply a force, the body expands or the elongates along this direction, and there is an additional length small l. So the strain will be this change in length or the additional length or the change in dimension to original dimension or original length. So this change in length is small l and original length is capital L. So longitudinal strain is small l by capital L, and longitudinal stress is force per unit area. So Young's modulus can be given as FL by AL. So the next type is, so this is the Young's modulus, and it is also known as Young's modulus is also known as elasticity of length. Elasticity of length, or the next modulus of elasticity. So the next modulus of elasticity is the bulk modulus, and in this the force is applied normally and uniformly along the surface of a body of area A, such that there is a change in volume small v in its original volume capital V. So in this case we apply a normal force, or the external force is applied normally through the entire surface of the body, causing change in its volume, and this additional volume increase or decrease in volume is given by small v, and the original volume was capital V. And then the bulk modulus K can be defined as F force per unit area upon small v by capital V, or the volume stress by volume strain. Here the negative sign indicates that as the pressure increases, this force by area term or the pressure increases, the volume decreases. Volume decreases, and vice versa. As the pressure decreases, the volume increases. This is why there is a negative sign here. And also, K is sometimes referred to as incompressibility of the material of the body, and reciprocal of K, that is 1 by K, is known as compressibility. 1 by K is known as compressibility. K is, I'll repeat, K is sometimes known as incompressibility of the material of the body, and 1 by K, the reciprocal of K, is known as compressibility. And another point to note here is that since liquids and gases can permanently sustain only a hydrostatic pressure, only elasticity they possess is the bulk modulus. They do not possess any other elasticity like Young's modulus or rigidity modulus. And the third type of modulus of elasticity that we will discuss today is rigidity modulus. And consider a body like this, a cube shaped body with one side capital L, one side of length capital L, and the area of one surface is A, which is L square. So here, if a tangential force F is applied along the upper face A, B, C, D, if a tangential force F is applied along the upper face and the lower face is fixed on a horizontal surface, here you can see an equal and opposite force is coming into play. Why? Because we are applying a force here. There is an equal and opposite force from the weight of the body on this surface. Here the body is resting on a surface and there is a reaction force from the surface. This equal and opposite forces forms a couple and this causes the rotation of the cube. We are applying a force here and the body is fixed in the lower surface. We are applying a force here and it acts as a couple and this causes the rotation of the upper layers of the body by an angle theta. So this force acts as a shearing stress, which is this force per unit area, causing a shearing strain theta. So the shearing stress is given by force, tangential force per unit area. Area is the upper surface, ABCD, which is L square, and force per unit area, force by L square upon theta. Theta is the shearing strain, which is the change in length, additional length small l, upon the original length capital L. So we can also define the rigidity modulus or the modulus of rigidity of a material as the tangential or shearing stress per unit shear. Tangential or shearing stress per unit shear.